Tonight, if you went outside and looked up and the moon was just gone, not behind clouds, not in a different phase, just completely absent from the sky, your first thought would probably be that something had gone wrong with you personally, because the moon has always been there. For every human who has ever lived, for every civilization that has ever existed, for the entire history of complex life on this planet, the moon has been in the sky. It is one of the most permanent fixtures of existence that we have. So what would actually happen if it wasn't? The answer is both faster and slower than most people expect. Some things would change within hours, some things would take thousands of years to fully play out, and the end result would be a planet that looks, feels, and functions in a way that is genuinely difficult to picture from where we're standing right now. Let's start with what you'd notice first: the tides. The moon's gravity pulls on the Earth's oceans, creating the bulge of water we experience as tidal movement. Without the moon, tides would still exist. The sun also has a gravitational pull on the oceans, but they would be dramatically smaller. Current lunar tides are about 2 to 3 times larger than solar tides. Remove the moon and you're left with weak, barely noticeable tidal movement compared to what we have now. This sounds like it might be fine, maybe even convenient. No more floods in low coastal areas, no more dangerous rip currents linked to tidal patterns. But ocean ecosystems are built around tides. The intertidal zone, that strip of coastline that gets covered and uncovered by water twice a day, is one of the most biologically productive environments on the planet. Thousands of species depend entirely on that rhythm. Remove it, and you're not just inconveniencing some crabs, you're dismantling a foundational layer of marine ecology that the rest of the food web sits on top of. Fisheries would be affected, coastal nutrient cycling would change. The mixing of ocean water that tides help drive, which distributes heat and nutrients across the ocean, would slow down. The effects would ripple outward in ways that are genuinely hard to fully model. But tides are just the beginning. The bigger, slower, stranger consequence of losing the moon involves the Earth itself, specifically the way it spins. Right now, the Earth rotates once every 24 hours. That familiar day-night cycle we all live inside is partly a product of the moon's influence over billions of years. When the Earth formed, it was spinning much faster. A day was probably only about 6 hours long. Over billions of years, the moon's gravitational pull has been gradually slowing that rotation down, acting like a kind of enormous distant brake. Without the moon, that braking effect disappears. The Earth wouldn't immediately speed up, it wouldn't snap back to a 6-hour day overnight. But over very long timescales, the rotation would stop being gradually slowed and would eventually be influenced more by other, less stable forces. Some models suggest that without the moon's stabilizing influence, Earth's rotation could gradually drift and become erratic over millions of years. But here's the piece that most people don't know about, and it's the most important consequence of all. The moon stabilizes the tilt of the Earth. Right now, the Earth is tilted at about 23.5 degrees relative to its orbit around the Sun. This tilt is what gives us seasons. It's been remarkably stable over long timescales, fluctuating only slightly, kept in check largely by the moon's gravitational influence acting as a kind of anchor on the planet's axial tilt. Without the moon, that anchor is gone. Computer models of what happens to Earth's axial tilt without the moon are genuinely alarming. The tilt could swing wildly over millions of years, potentially anywhere from near 0 degrees to over 80 degrees. A tilt near zero means almost no seasons. The poles would be in permanent twilight, the equator would dominate the climate, and the entire band of seasonal variation that drives agricultural cycles, animal migration, and a huge proportion of Earth's ecological rhythms would essentially disappear. A tilt near 80 degrees would be catastrophic in a completely different direction. At that angle, the poles would point almost directly at the sun for half the year, getting cooked while the rest of the planet freezes. Then it would flip. The temperature swings would be so extreme that most complex life as we know it would struggle to survive them. Mars, which has no large moon to stabilize it, has had its axial tilt vary from near zero to over 60 degrees over geological time. The result is a climate history of extreme swings that is part of why Mars looks the way it does today. Earth without its moon could eventually follow a similar path. There's also the question of what we lose culturally and psychologically, which sounds soft until you actually think about it. The moon has structured human life since before recorded history. The first calendars were lunar. The words month and Monday come directly from the moon. Menstrual cycles, agricultural planting schedules, religious festivals, navigation systems, poetry, mythology, virtually every human culture that has ever existed has organized significant parts of its life around the moon's phases and its presence in the sky. Removing it wouldn't erase all of that immediately, but the generations that grew up without it would live in a different psychological relationship with the sky. The night sky itself would be dramatically darker. The moon at full phase is bright enough to cast shadows. Without it, the stars would be more visible, which sounds nice, but the total darkness of moonless nights would fundamentally change how people relate to and move through the night. The short answer to what happens if the moon disappears is, immediately, the tides shrink and coastal ecosystems start to destabilize. Over centuries, the effects spread through marine food webs and coastal environments in ways that ripple inland. Over millions of years, Earth's axial tilt could begin to drift toward extremes that would make the planet's climate dramatically less stable than it is today. The moon feels like a backdrop, like scenery, like something that's just there, but it turns out it's been doing an enormous amount of work this whole time, quietly, from 384,000 kilometers away, holding everything together.